So, hello dear student. Today we will see the first chapter from the organic chemistry having name halogen derivative. Okay. So as you know very well that in our chemistry mainly paper 1 contain physical chemistry and little portion of the inorganic chemistry, and paper 2, that is called section B, contain entire organic chemistry and little bit amount of inorganic chemistry. Okay, so right now we will switch on paper 2 section B, first chapter, halogen derivative. You may call it as a basic chapter of the organic chemistry. Okay, now this chapter is very important because the rest of the study of the remaining chapter is based on the concept coming from this chapter, and that's why the study of halogen derivative become initiative or necessary. So without wasting a moment, directly we start halogen derivative. Okay, so halogen derivative means what? Initially we will see, we will throw a light on the basic or fundamental halogens. We know our long form of periodic table, it is made up of how many columns, how many groups? See here, it is made up of 7 periods. How many periods? 7 periods and 18 columns, that is called groups. Okay, out of that what happened? 17 group family, 17 group family, that is the halogen family, that is called what? Halogen family. For example, fluorine, chlorine, bromine, iodine and aspartame. Okay, so 1, 2, 3, 4, 5. These are the halogens. These are the halogens which belong to the 17 group family. So as we are studying the title halogen, therefore you must know the position of the halogens. What is the position of the halogen? The position of the halogen block P block. Which block? P block. In that second to 7th period, in that second to 7th period, and what is the column number, group number? 17 is the group number. So this is the position of the halogen. Now what is meant by halogen derivative? Okay, so here the concept of alkane, alkene and alkynes are very important. In last year you may have studied about the alkane, alkene and alkyne. So what is alkane? Aliphatic saturated hydrocarbon. Okay, so what is alkane? Aliphatic saturated hydrocarbon. For example, see here C, etc. Okay, if every carbon is surrounded by, binded by only a single covalent bond, then it is called as the aliphatic saturated hydrocarbon. What is this? Aliphatic saturated hydrocarbon. If same structure is here, but if it is bounded by at least one double bond, then it is no more aliphatic, it is the aromatic. Okay, it is the aliphatic, it is the aliphatic, not aromatic, it is the aliphatic unsaturated hydrocarbon. Okay. So without wasting moment, directly we start what happens to that. Now see here, for example, let us take the example of methane, halogen derivative. What is meant by halogen derivative? See here, derivative, question mark. Okay, for example, CHH. Everybody know this is nothing but your methane. Okay, now what happened? From this methane, if I replace this hydrogen atom with halogen, X denote halogen family, X denote halogen member. Okay, so addition of halogen and removal of hydrogen. So here what happening? One hydrogen is removing and one halogen is adding. Therefore the structure will be like this. Okay, H and it is the X. Okay, so this is called as the derivative. Derivative means what? Product. Derivative means what? Product to obtain. So how this product obtained? This product obtained via removal of the hydrogen atom and addition of the halogen atom. Therefore halogen derivative is also called as, it is the replacement of one or more hydrogen atom. Okay, replacement of one or more hydrogen atom from aliphatic or aromatic hydrocarbon. Okay, aliphatic or aromatic hydrocarbon with the help of halogen, then it is called as the halogen derivative. Okay, so this is simply called methane. What is this? This is simply called as methyl halide. This is what? Your methyl halide. If here in place of X there is a Br, we will write here what? Br. It will become what? Methyl bromide. What is that? Methyl bromide. So this is your halogen derivative. So what is halogen derivative? Halogen derivative is nothing but the replacement or substitution of one or more hydrogen atom from aliphatic or aromatic. अब aliphatic and aromatic, what is meant by aliphatic and what is meant by aromatic? So let us see afterwards, or after definition I will explain. Okay. So then it's very important to know classification. Classification. See here. Classification of halogen derivative, HD. Okay. So halogen. See here. Halogen derivative. See carefully what I am saying. Halogen derivative. Okay. Halogen derivative mainly classified into two types. Listen here. In examination question can be asked, how will you classify halogen derivative? So halogen derivative is classified mainly into two types. Which one is the polyhalogen derivative? What is that? Polyhalogen derivative, and here monohalogen derivative. Okay, now mono and poly means what? Obviously here mono is nothing but single one. So when there is a replacement of one hydrogen atom by one halogen atom, it will be known as monohalogen derivative. Okay, and if replacement of two or more hydrogen atom, replacement of minimum two or more hydrogen atom by halogen atom, then it will be known as polyhalogen derivative. Okay, so this is the main classification. What is the main classification? Monohalogen derivative. If only one hydrogen is replaced by halogen atom, it will be known as monohalogen derivative. For example, example we will discuss later. Okay, and what is polyhalogen? Polyhalogen is replacement of more than two. Okay, two or more hydrogen atom, then it will be known as polyhalogen derivative. Now our classification do not stop here. See here what our classification do not stop here. Further, polyhalogen derivative can also be classified as, see here, dihalogen derivative. Okay, dihalogen derivative. Here trihalogen derivative, and here lastly tetrahalogen derivative. Okay, so polyhalogen derivative, dihalogen derivative, trihalogen derivative, and tetrahalogen derivative. So see here, if two hydrogens are replaced by two halogen atom, it is called as dihalogen derivative. For example, see here CHHH. Okay, I am replacing here. What happened? Br and Br. See here, two halogen atom replace two hydrogen atom. Therefore, this is the case of dihalogen derivative. In case of trihalogen derivative, see here H. Here I am replacing what? CBr number 1, okay, Br number 2, okay, and here one more Br number 3. So such a type of derivative is called as trihalogen derivative. Similar to that, tetrahalogen derivative, it will be direct. I am writing example Br and Br. So this is the simple classification of the halogen derivative, monohalogen derivative, and polyhalogen derivative. Now next question is there. Now you may understand this classification. Okay, I will go in detail after that. Just try to see halogen derivative, monohalogen derivative, polyhalogen derivative, dihalogen derivative, replacement of two hydrogen atoms by two halogen atoms. Okay, see here, this X is nothing but your halogen. It may be Cl, it may be Br, it may be R. Okay, in general it is written as a X. Now dihalogen derivative, replacement of two hydrogen by two halogen, replacement of here three hydrogen by 3 halogen, okay, and here replacement of 4 halogen by 4 halogen, hydrogen by 4 halogen. Now next question is there. See here, mind the question. What is mean by monohalogen derivative of the alkane? Halogen derivative. What is mean by monohalogen derivative of the alkane? Now this is the question. So monohalogen derivative of the alkane is defined as when there is a replacement of only one hydrogen atom by one halogen atom. Here I am making example CH4, okay, replacement of one hydrogen atom, replacement of one hydrogen atom via one halogen atom, which will be known as CH3X. This is called as the monohalogen derivative of alkane. Monohalogen derivative of alkane. Rest of the idea about polyhalogen is given here. You may follow textbook as well as this understanding. Okay. Now see here. Again, let us extend the classification. Now you are very now you may think here, what happened to that monohalogen derivative? Now remember, I am explaining same thing in another way. Okay, so let us write the example CH3 CH2 Br. Everybody know this is your ethyl bromide. This is your ethyl bromide. So structurally we can write like this: H H H H and Br. Who is the parent alkane here? Ethane is the parent alkane. One of the hydrogen of the ethane replaced by halogen Br. Therefore, this is the exact proper example of monohalogen derivative of alkane having name ethyl bromide. Having name what? Ethyl bromide. Okay. Now see here. In this case, I am talking about number A classification. What is that? Monohalogen derivative. Okay. So in this case, what happened? The halogen atom is attached to that carbon atom which is sp3 hybridized. What is that? It is sp3 hybridized carbon atom. So remember, only singly bonded carbon atom can be or is the sp3 hybridized carbon atom, and in case of monohalogen derivative, it is the sp3 hybridized carbon atom. Okay. After that, next, dihalogen. Okay, dihalogen means what? B, dihalogen derivative. Okay. So here what happened? See here. In dihalogen derivative, there are two type of cases. Let us discuss one by one. First, we write the example CH3, CH, Br and Br. So what happened? Everybody see here. Here two hydrogen atoms are replaced by two halogen atom, bromine atom. Okay, therefore it is the dihalogen derivative. Now see here. Dihalogen derivative are of two types. See here. Which one? Vicinal. Okay, vicinal and geminal. Of course, they are dihalide. They are dihalide. Vicinal dihalide and geminal dihalide and vicinal dihalide. Now, what is the difference? Of course, in both cases, what is common? In both cases, it is common that two hydrogen atoms are replaced by two halogen atoms. So, we write example. See here, CH2, CH2. Now, here, see here carefully. What happened? Here, two halogens are attached to the different carbon atom or adjacent carbon atom. Different carbon atom or adjacent carbon atom. Such a type of derivative is called as the vicinal dihalide. When both the halogen atoms are attached to the same carbon atom, CH3, CH, Br and Br. In this case, it is called as geminal dihalide. What is the difference? Here, halogen atoms are attached to other carbon atom, different carbon atom. Here, halogen atoms are attached to the same carbon atom. So this is called as the vicinal dihalide and geminal dihalide. Okay. After that, number C. What is that? Trihalogen derivative. See here, in short, I am writing trihalogen derivative. So here, Br, Br and H. So this is the example of trihalogen derivative. In nomenclature we will see their names in detail. Okay, so don't worry right now. Of course, lastly tetrahalogen derivative. So CCl4 carbon tetrachloride is the best example of tetrahalogen derivative. Best example of tetrahalogen derivative. Okay, now so here I am switching off the classification, general classification of the halogen derivative. Now again back to the monohalogen derivative. Question is there, what are monohalogen derivative? Question mark. How are they classified? Okay, so what are monohalogen derivative? Already I explained. Now let us see their classification. So what happened? The classification of monohalogen derivative, be careful, is depend on the classification of carbon atom. Depend on the classification of carbon atom. Like this. See here, primary alkyl halide. Okay, always remember monohalogen derivative is nothing but the alkyl halide. Yes or no? Alkyl halide, in short we can write RX. Where what is R? R is the alkyl group, X is the halide. So primary alkyl halide you can write 1 degree like this, number B. Secondary, that is 2 degree alkyl halide, number C. It is the tertiary, that is 3 degree alkyl halide. Okay, now already I told you the classification of monohalogen derivative is depend on the classification of carbon atom. How carbon is classified? See here. For that purpose I would like to draw one figure here, one diagram structure C. Okay. Now suppose let us write this diagram. Now what is mean by primary carbon atom? What is mean by secondary carbon atom? What is mean by tertiary? If you understood this, you can easily understand this classification. Okay. So first we should be clear in classification of the carbon atom. So the carbon atom which is attached to only one carbon atom is the primary carbon atom. So this is your primary carbon atom. 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 See here, this carbon atom is attached to only one carbon atom. Okay. Now secondary carbon atom. Secondary carbon atom. Secondary carbon atom is called that carbon atom which is attached to two other carbon atoms. For example, this carbon. This carbon atom is attached to this carbon atom as well as this carbon atom. Therefore, it is the 2 degree. About this carbon atom, it is also 2 degree. This carbon atom 2 degree. You know why? Because this carbon atom is attached to this carbon and this carbon. Okay. After that, this carbon is also a 2 degree carbon atom. This carbon also a 2 degree carbon atom. Okay. Now tertiary carbon atom. Tertiary carbon atom is that carbon atom which is attached to 3 other carbon atoms. Which is attached to what? 3 other carbon atoms. So everybody see here. If we write like this, C. Now see this carbon atom. This carbon atom is attached to 1, 2, 3. Therefore, such a type of carbon atom is called as tertiary carbon atom. Okay, tertiary carbon atom. Now, this is also your primary. This is also primary. After that, quaternary carbon atom, that is 4th degree carbon atom. So, carbon atom which is attached to 4 other carbon atoms. 1, 2, 3, 4. So, such a type of carbon atom is called as the quaternary carbon atom. Okay, so this is the classification of the carbon atom. Now, how we can apply this classification to our wanted classification of the monohalogen derivative? So, what are monohalogen derivative? Already I told you. How are they classified? They are classified in this way. So, primary alkyl halide. Primary alkyl halide is nothing but alkyl halide in which halogen atom is attached to primary carbon atom. You know about the primary carbon atom. See here. CH3, CH3, sorry, CH2, CH2. On here directly we write Br. Now what happened? See here. The halogen atom is attached to such a carbon atom which is primary in nature. Okay, primary, that is 1 degree, or you can simply say sp3 hybridized. Now such a type of example is the primary alkyl halide. Another example of primary alkyl halide, CH3, CH3, 1 2, CH2, CH3. Sorry, Br. Now see here. Now you may think whether it is primary or other, because here we are finding out straight chain, branch chain, therefore confusion can be there. But remember, you have to find only the position of Br. Okay, you have to go for the position of Br. Now Br is attached to the primary carbon atom, therefore this is also a primary alkyl halide. This is also a primary alkyl halide. Okay, now so you got the idea. While determining the classification, you have to note only the position of what? Position of halogen, to which carbon atom it is attached, whether it is primary, secondary or tertiary. Now back to the secondary alkyl halide. Secondary alkyl halide is that alkyl halide in which halogen atom is attached to the secondary carbon atom. So let us write example of that. See here, for example, CH3, CH3. If I write here, okay, very clearly, this carbon atom is secondary, because this carbon atom is attached to this carbon atom as well as this carbon atom at the same time. Therefore, the nature of this carbon atom is secondary. Such type of alkyl halide is called as a secondary alkyl halide. Next, tertiary. In tertiary, what happened? In tertiary alkyl halide, halogen atom is attached to 3 degree carbon atom, tertiary carbon atom. So see here, in the same case we can write, if I remove this hydrogen atom and add one of the methyl group here, what happened? Now nature of this carbon changes. Say yes or no? Nature of this carbon changes. Now it will become tertiary carbon atom. We are attached to tertiary, therefore it is the 3 degree alkyl halide. It is the 3 degree alkyl halide. Okay, so in this way we can have the classification. Okay, now again many more type of alkyl halides are there. Okay, see here, alkyl halide. Now I am ending the video, the first video. Okay, alkyl halide you know very well. After that, see here, vinyl in short. Okay, dihalide, you know about this. After that, J-vinyl, dihalide, you know very well about this. Now new form, allylic halide. What I am saying? Allylic halide. Allylic halide means what? Everybody see. You will define letter. Allylic halide. I am writing C Br. Okay. Just go through the basic. Allylic halide means what? Okay. So if I write here double bond, the valency of carbon is 4. 1 2, therefore I should write here 2 hydrogen atoms. 1 2 3 4. समझ लो. After that 1 2 3, so 1 hydrogen should require here. Okay, 1 2 being tetravalency, I must write here 2. Okay, now such a type of alkyl halide is called as the allylic alkyl halide. So how to define allylic alkyl halide? Allylic halide is defined as the halogen atom attached to such a carbon atom which is next to the double bond. So CC, this is the accurate position of the allylic carbon atom. This carbon atom is called as allylic carbon atom. समझ लो. What is mean by allylic carbon atom? What is mean by allylic halide? Allylic halide is that halide in which halide atom is attached to allylic carbon atom. So what is mean by allylic carbon atom? Allylic carbon atom is always next to the double bond. It means after double bond, whatever carbon is available, that is called as allylic. Okay, so see here, C double bond C, C double bond, sorry, single bond C. So this is your allylic carbon atom, this is your allylic carbon atom. Both carbon atom, both boxes carbon atom are next to the double bond. Such a carbon atom is called as allylic carbon atom, and whenever any halide attached to them, it is called as the allylic halide. Okay. After that, new, next new, vinylic, vinylic halide. Try to understand the difference between allylic and vinylic. Allylic, sorry, vinylic means what? Okay. I hope you got the idea of the allylic carbon atom. Now vinylic means what? If I write like this, C double bond C, if I write here X, now what happens? When halogen atom is directly attached to the doubly bonded carbon atom, that is also called as sp2. This carbon atom is sp2. Always remember, single bonded carbon sp3, double bonded carbon sp2, triple bonded carbon sp. Okay, so if such a type of structure is there, halogen atom directly attached to doubly bonded carbon atom, then it is called as vinylic halide. For example, CH2, CH, we can replace. So this is called as vinyl bromide or ethylene. Don't worry about the name, we will see later. Ethylene bromide. Okay. So it's very simple, don't worry about this. After that, new, benzylic halide. Very important category. In order to switch on next concept, this type of derivative we must know. Benzylic halide means what? So listen carefully what I am saying. Everybody know what is this? Initially we will start 1, 2, 3, 4, 5, 6. No double bond, that's why it is the saturated compound. So this is called as the cycloalkane. कितने कार्बन है यहाँ पे? 1, 2, 3, 4, 5, 6. It means it is the cyclohexane. If I write here ring, it become benzene. Okay. What is the molecular formula of benzene? C6H6. Now keep in mind we are trying to study benzylic halide. Okay. So benzylic means what? If I attach one of the carbon atom to the benzene ring, if I attach one of the carbon atom to this benzene ring, then this carbon is nothing but your benzylic carbon atom. Which carbon atom? Benzylic carbon atom. And if I attach any halide here, it will become benzyl halide. कौन सा halide है यहाँ? Bromide. Therefore, it is called as the benzyl bromide. Okay. Now satisfy the valency. You know tetravalency of carbon atom 1, 2. Therefore, I should write here how many hydrogen? 2 hydrogen. Okay. So this is the exact perfect example of the benzylic bromide. Now next new haloarine. Harine nahi, haloarine. Haloarine means what? What is the difference? See here, I am writing again cyclohexane, benzene. Now, what is the difference between these two? Here, halogen is directly attached to benzene. Here, halogen is attached to such a carbon atom which is directly attached to benzene. That is the difference. Instead of X, we write here this one. So this is the example of haloarine having name bromobenzene. Okay. So this is for today. So chapter halogen derivative. In that we have seen basic definition, basic start, basic fundamental. Okay. After that we have defined and classified. In next part we will see the nomenclature in detail. Okay.